Hello and welcome to Vaslav's Maths tutorial. I'm going to do a question from C4 past exam papers. That's question 2 in June 2012. Pause the video and read the question carefully before we proceed. We have been given a cube of side x, and we have been told that this metal cube is expanding at a constant rate. And part A is asking us to show that dv dx is equal to 3x squared. Well, we know that the volume of a cube side x is given by x times x times x, and that is x cubed. So if we differentiate that dv dx, we get dv dx to be equal to 3x squared, okay, as required. So that's part A. Part B, then it says if the volume is increasing at constant rate of 0.048 centimeter cube per second, find dx dt when x is equal to 8. Well, the key here is to recognize what we have been given. We have been given the rate of change of the volume, so we have to recognize that as dv over dt. By looking at the dimension, we can see that is the volume divided by time, so that is equal to 0.048. Part B, it's asking us to work out dx dt. In order to do that, we can use an intermediate variable to aid us to work out this problem. That intermediate variable in this case has to be volume, since we've been given some information regarding volume. So keep dx the same, but then I'll divide by dv and times by dv, so that I can maintain the balance of the equation. So the left hand side of the equation is exactly the same as the right hand side, but on the right hand side I've got enough information to solve the problem. Okay, dx dv, we got that's here. Well, we got dv dx, so therefore dx dv must be the reciprocal of that, so that would be 1 divided by 3x squared, and dv dt is given to us to be 0.048, and we're asked to work this out when x is equal to 8 centimeter. So the next things to do is to substitute for x equal to 8, and we get a numerical value for dx dt, 1 over 3 8 squared times 0.048, and implement that on the calculator. Okay, that gives us 2.5 times 10 to the power of minus 4, the unit centimeter second. Okay, so that answers part B, and let's do part C now. Part C is asking us to work out the rate of increase of this total surface area of the cube, again when x is equal to 8. Well, let's find out the total surface area of a cube. We know that the cube has got 6 surface area, of each surface area being x squared. So the total surface area of a cube is 6x squared. Okay, now we've been asked to work out dA dt, very much the same as part B, but this time is the rate of change of surface area, total surface area we've been asked to work out. Again, I can bring in another variable to aid us to solve the problem, and this time that intermediate variable is going to be x, and we see why. If I write again dA just like that, and then divide by dx and times by dx, and write down dt, then again I've kept the balance so that the left hand side of the equation is exactly the same as the right hand side. As you can appreciate, these two would cancel out. So the next thing to do is to work out a value for dA dx. I can do that by going here and differentiating with respect to x. So I can say dA dx is equal to 12x. Okay, so now I can plug that in here. So that's 12x, then multiply by dx dt. That information was given to us, well, we worked it out in part B, to be 2.5 times 10 to the power of minus 4. Again, we have to do this for when x is equal to 8 centimeter. So next thing to do is to go and substitute a value for x times 2.5 times 10 to the power of minus 4. Again, if you do that on the calculator, we're going to get to be equal to 0.024 centimeters squared per second. Okay, so that's part C. I suggest that now you go and try the problem again independently without looking at the solution, and see how you get on, and then refer to the solution if you get stuck. Thank you.